So when we classify chemical reactions, there are two different approaches. One is to classify the reaction by what happens. And here's a flow chart showing that, and that's what we've been talking about today. Precipitation reactions where solid forms, acid-base reactions where you have an acid and a base reacting to form water and a salt, gas evolution reactions where we get a gas being formed, oxidation reduction reactions where we have electrons being transferred. And then a subcategory of oxidation reduction is combustion. All combustion reactions are oxidation reactions, but not all oxidation reactions are combustion reactions. And there are some reactions that fall into more than one category. We can also focus on what are the atoms doing. And so we have some slightly different names for the types of reaction. So here a synthesis or combination, I prefer combination, is where you have two substances combining to form one substance. Decomposition is the opposite. You have one substance falling apart or decomposing to form two new substances. We can have displacement. Sometimes this is called a single displacement. And so here you have a guy going stag to the prom, and here's a couple going to the prom, and something happened at the prom, and the girl ends up leaving with this guy, and poor B goes home by himself. That's a single replacement. One person is getting replaced. One ion is getting replaced. Or we can have double displacement, and we've done a lot of those today, where we have two couples, and they swap partners. Two people are being displaced. In a synthesis reaction, we got two simpler substances combining to make something that's more complex. An example of this is you can take sodium metal, which is a very reactive, soft metal, and chlorine gas, which is toxic. You can combine those together and form sodium chloride, which you can sprinkle on your meat and eat it, and it's not going to harm you at all. Here's the equation. Sodium plus chlorine gives us sodium chloride. We recognize this as a combination reaction because we have one product, the two things combined. Decomposition, we got the opposite. So here we have a 9-volt battery and a beaker of water, and bubbles form. And what's happening is the electricity is decomposing the water. So the water is coming apart into its components, hydrogen and oxygen. Decomposition. One reactant, more than one product, the opposite of combination. Displacement or single displacement. If you take a piece of zinc metal and you put it into a solution containing copper ions, the chloride ions are just spectators, copper ions, the zinc metal will become copper colored. And the reason that happens is that we have a displacement. We should have an equation here. There's no equation. I'll make an equation. So zinc solid plus copper 2 chloride. We're going to end up with copper metal and zinc chloride. The copper in this compound was displaced. A single element was displaced. Single displacement reaction. That is also an example of an oxidation reduction reaction. And then we can have a double displacement. So then you have two elements or two groups of elements in two different compounds, and they're swapping partners. And lots of those other categories fall into this description. So precipitation reactions are double replacement reactions. Acid-base reactions are double displacement reactions. Many of the gas evolution reactions are double displacement reactions. So there's two kinds of classifying. Looking at what the atoms are doing, or looking at, a more macroscopic picture of what's happening. Oh, it's bubbling, it's a gas evolution reaction. Oh, there's electrons being transferred, or, oh, there's a solid forming. It's a precipitation reaction. So this flow chart for what the atoms are doing, we end up with synthesis, decomposition, single displacement, and double displacement. So let's classify. A given chemical reaction may fit into more than one category. On the exam is multiple choice. There will be only one correct. I'm not going to ask you to pick all the correct ones or anything silly like that. So here we're given the choices: synthesis, decomposition, single displacement, or double displacement. Let's look at letter A. What kind is that? Single displacement. Here we've got aluminum as an element coming in by himself. He's leaving with phosphate. Hydrogen came in with phosphate, and poor hydrogen's leaving by himself. So that is single displacement. We'll call that SD. SD. How about letter B? Double displacement. The copper and the potassium are swapping partners. How about letter C? That's a synthesis or combination, because we have two things and only one product. How about letter D? That's a decomposition. Any questions? That's something you definitely should be able to do, because there will be questions like that. It's not too hard.
About 40 of them?
About 40 of them. Something like that, yeah. So, chapter and review slides. I don't know why that's there. Those are more examples. I don't want to do them.